Hello, this is Year 12 Maths. This is exercise 6A, and really it's just building on what you've seen at GCSE in terms of what we would call coordinate geometry now at A Level Maths. So we're going to do a lot of stuff on, well, it says here, lengths, midpoints, gradients, that kind of stuff, and then it'll build into other more complicated stuff. So midpoints, gradients, lengths, let's have a look. Now first of all, a couple of starters. Expand and simplify. You should be able to expand these if you know how to deal with powers and stuff. So don't forget, squared means one of them is times by the other one of them. So multiply those out. Likewise to that one. This one is obviously root x. This says cube, so it's times root x times root x. Now you might want to do it as a power with a number, or you might think, well, I know what two of them, for instance, gives you. And there, this last one, you've got to multiply out this by this. You get your answer to the first two, and then you times it all by x plus 3. So that was on GCSE as well. So you should have 4 answers. Pause the video, make sure you're happy with them. If not, come and see me. So anyway, here's the answers. Hopefully you've got them right. And there they are across the bottom. So fingers crossed you've got those right. So come and see me if you haven't. Well, this, by the way, this one I was thinking of, you could write this as x root x. A lot of people write it like that instead, because root x times root x is just x, but you've still got root x left over. So anyway, second starter, this is you're meant to work out the length of the sides, and this is obviously Pythagoras' theorem. And the reason why you're doing this is because there's a lot of Pythagoras and simple maths like Pythagoras in coordinate geometry. So I'll do the first one for you. You should remember that a squared equals 6 squared plus 8 squared. Sometimes it adds something like this one here. Notice this one and this one, by the way, are the same. So you can still do that. This one here, actually, this is the one. This will be a subtraction because I don't want the hypotenuse, I want the side. And likewise this one here as well. This d will be found using the subtraction. But this first one's an addition. A squared, if you do that, 36 plus 64 is 100. Well, that's a really nice one. A equals 10. It will always be nice if you get a... You can do it on your calculator. If you get a nasty answer, just write root 43 or whatever it is. So pause this, see if you can do questions 2, 3 and 4. Okay, here's the answers. What have I got? Yeah, just about see them on the bottom there, can't you? Hopefully you got those right, and then we move on. So a distance between 2 points. Now, notice I'm doing this in the general case first of all. We've got this coordinate down here, it says minus 2,2. Coordinate over here, 1,3, and I want a formula for the length of the line. Look, let's be honest, it's Pythagoras. You draw a line going across, you make sure it's a right angle triangle, therefore it's a line going down, and you say to yourself, well, look, this is what I do. I'd goes from 1 that way to minus 2. You can either count, or you could take away that 1 take away and minus 2 is 3. And if we do the same thing going up, you can obviously count again, 1, 2, 3, 4, 5 up, or you could do 3 minus the minus 2, and that's the mere fact I'm stressing the negative nature of these implies that's probably the way we do it for real. So I've got 3 and 5 as well, and notice what you now do, a bit of Pythagoras. 3 across, 5 up, 3 squared plus 5 squared, square root your answer, root 34. So it's relatively easy, it's not a problem. More generally then, say you don't know what the coordinates are. Now, you could always, if you're given the numbers, you can always just do what we've just done. Draw a little picture and do it. This is the formula you tend to find in exam books and in textbooks and stuff. So notice you start with the x values. It doesn't matter which one you start with. Pick one of them and do that one minus the other one. So x2, take away the x1 and square the answer. Then you take your y values. Same one for ideally. y2 minus y1, square your answer. Then square root the answer. So that's the formula. This is a posh formula for something which is really not that hard. Okay? And it's basically Pythagoras' theorem, as it says. So if I do this here, this is what I'd do. If it was me, I'd draw the 4, minus 3. Oh, it's not a very good picture, it's down there. So let's try and get the picture roughly right. And it says minus 1, 2. I'll draw this right the right way. I think it's up there. So there's my B, minus 1, 2. And this is my A, which is 4, minus 3. And I'll draw a line joining them up. Draw your little triangle. Now you say to yourself, how far has it gone across? And it's obviously gone minus 4, So minus 1 up to 4 is 5. And again, if you use the formula, you do 4 minus the minus 1. 4 minus the minus 1, which is 5. Now going up and down, you can see it goes from 2 down there, and then another 3 down to get to minus 3. I think it's 5 again, using the formula. Now last time we did the 4 first, so I'll pick the minus 3 first. Minus the minus 2. So technically this is minus 5, but of course we don't care whether it's plus or minus. Not for this anyway. We would if it was the gradient, but not for this. It's just 5 down. So the length is AB is a square root of 5 squared. That's another 5 squared. That's 25 plus 25. That's root 50. And you probably are going to be asked to leave these in surd form. So that's 25 times 2 all square rooted, which is 5 root 2. Now that obviously has a decimal equivalent as well, so I don't know if I've got that. No, I've just got 5 root 2. 5 root 2 is a better answer for A level maths. So here's the next stage of this, which find the midpoint of what we'd call a line segment. And the line segment is just, this is all they mean by a line segment. A line segment basically stops. My pen's gone. Oh, what's that? So I've got that point there, I've got that point there, and if it was a line, it would carry on forever. But this one's saying it's a line segment, so it's only part of it. But that's not really important. If I want the midpoint, it's telling me the clue here, it's the average of these other points. So all I do, and this is the little trick, I say 1 plus minus 2. So I'm just going to write here, 1 plus minus 2 is minus 1. And I'll do the other one as well, 3 and minus 2. So I'll go 3 plus minus 2 equals, well that's 1. So 1's a minus 1, 1's a... Now with both these answers, I then have to halve them. I find the average of them. So I divide by 2, and that gives me minus a half for that one. And this one gives me a half. 1 divided by 2 is a half. So the midpoint of this point, from 1, 3 down to minus 2, 2, the midpoint must be minus a half, comma a half. Now of course we knew that anyway, you can see on the picture. That looks like minus a half, comma a half. It just kind of works. But we haven't always got pictures, and therefore we need this method just to be, you be able to use it. Now the midpoint formula then, again, the same as last time, you just write, well, let's do what we just did. We added them together, x1 plus x2. Don't forget to divide by 2. y1 plus y2. Don't forget to divide by 2. And I will say this, when you're doing this, it seems tempting to just do it a different way. For instance, I mean, here we've got an example. I think it's the same example as last time. We had 4 minus 3 down here. And we had b equal to minus 1 comma 2. And if I want the midpoint of that line, it's around here somewhere. I'm not exactly sure where it is. So now I'm going to use my formula first of all, and then I'll talk about the alternative way that most people tend to do it instead. So add the two numbers together. I've got minus 1, I've got a 4. So I'm going to go 4 plus a minus 1 divided by 2. There's the x's done. I'll do the y's. That's a 2 and a minus 3. 2 plus a minus 3 divided by 2. Just work them out. 4 plus a minus 1 is 3. Divided by 2 is 1.5. So I was right to draw it slightly this way. 2 plus a minus 3 is minus a half. Divided by minus 1 divided by 2 is minus a half. I was actually wrong to do that one. It should have been slightly under the line. But you get the idea. That's the right answer. Of course, it's probably better written in fractions. Now, fractions wise, it's 3 over 2 comma minus 1 over 2. But it's the same thing. You'd get the marks either way. Now, some people prefer, by the way, to kind of work out the distance between them. They go minus 1 to 4 is 5. Half that is 2.5, and they either add it onto this one or take it away. This process, if you do that, is slower. There's more steps to do. So this is, I would highly recommend this step. It's a quicker method than any you can invent. Now, k-value questions. K-values are always in questions when they're trying to make a question a little bit more difficult. And this is one of those. It says the distance between 2, k and 6, 5k is root 65. Notice, they're telling me the answer. The answer is root 65. And really they're saying, what coordinates get you that answer. So if we just have a look at this now, we've got, and I don't really know, you see, 2 comma k, I don't know what k is. K could be anywhere. That could be there, and then 6 comma minus 5k. It could be down there, but it could be anywhere. So this is where we fall back on our rule, our distance formula between 2 points. We know is the square root, and it said x2 minus x1, square it, plus y2 minus y1 squared, and then we square root it all. So let's just go with that. We know the answer is root 65. Root 65, and that is equal to the square root. Now it says take away the x coordinates. So I might as well do that one. Take away that one. 6 take away 2. Well, I'll write it down. And I'll obviously in a bit write 4, but just for completeness. And then I do the other one. It's minus 5k, so plus a minus 5k. Notice I started the 6, so I start with a minus 5k. And I've taken away that k. Squared. So, okay, let's carry on. Root 65 equals the root. Now this is 6 minus 2, which is 4. And if I square it, I get 16. It's easy enough. Minus 5k minus another k is actually minus 6k. Well, minus 6k, if I square it, is 36k squared. Oh, right. Notice I've got a square root of something. It was a square root of something else. So get rid of the square root. 65 equals 16 plus 36k squared. Move the 16 over. That sounds to me like 36k squared equals 49. K squared equals 49 over 36. And k therefore is equal to, if I square root 49 over 36, I get 7 over 6. Not quite actually. Or it could be minus 7 over 6. Does it say it's... No, it could be either. It doesn't say it's positive or negative. I've written plus or minus 7 over 6. Another question for us. I think we've got time to do it. The midpoint of A and B. So again, it's a backward question. You can see, because they tell me the midpoint is this. Do they know? They tell me the midpoint is this, where A is this and B is this. Find the values of A and B. Okay, let's do this. Now I've said the midpoint is you add the two values together. So I get minus 2A plus minus 6B, and then you half it, comma, and then I do the same thing for the y coordinates, minus 2B plus 10A divided by 2. Now let's just simplify that a bit. Dividing it by 2 just makes it a bit easier, doesn't it? Minus A minus 3B, comma, divided by 2, I get minus B plus 5A. Well, I think this is simultaneous equations because they tell me that is actually equal to 5 comma minus 4. So I reckon minus A minus 3B equals 5. I reckon, well, I'm going to write it in a better order. Put the B first, last, sorry, minus B, and the 5A goes at the front. And that equals minus 4. Okay, what we're going to do, I quite like the idea of timesing that top equation by, let's say, in fact I'll times the bottom equation by 3. And that will give me minus A minus 3B equals 5. If I times the bottom equation by 3, I get 15A minus 3B equals minus 12. And there's a rule that basically says if the signs are the same, or the things you're trying to get rid of, add them together. So we're going to add these together. 15A plus a minus A is 14A. Minus 12 plus that 5 is minus 7. I reckon A is minus a half. And what's my B equal to? Well, I know 5A. Well, that's 2.5. Oh, that's not, it's minus half, so it's minus 2.5. Minus the B equals minus 4. Now, first of all minuses make more pluses. It's a little trick. And I reckon B is 1.5. Or probably better written as 3 over 2. Let's see if I've got those answers right. Oh, I got minus 3 over 2. Well, I'll leave you to decide if I've got that right or wrong. It could be either, and I'll run out of time, so we'll worry about that in class. But I put just a quick glance, think it is 3 over 2, but it could easily not be. Won't worry about too much of that. In class, we're going to do exercise 6A. Fingers crossed that all works, and then we'll have a look at that in lesson.